Hey everyone, ready for another deep dive? Today we're tackling something that's got me pretty excited, a quasar. But not just any quasar. This one's got some serious quirks, let's just say.
Quirks is putting it mildly.
Yeah, fair enough. I guess wildly flickering is more like it.
There you go.
We're diving deep into an article from Unlocking the Universe's Dark Ages, how a quasar's wild flicker could change cosmic history. And I'm hoping we can figure out why this discovery is causing such a stir.
And what it might tell us about the universe back when it was still a baby, basically.
Right. The good old dark ages of the universe, before the first stars even thought about switching on. But before we get ahead of ourselves.
Yeah, let's back up a bit.
For sure. Could you give us a quick refresher on what quasars actually are and why they're so crucial for understanding, the early days of the universe?
All right, so picture this. You've got this beacon, right? A cosmic lighthouse. But instead of guiding ships, it's outshining entire galaxies. That's a quasar for you.
Wow, talk about a cosmic spotlight.
You got it. They're powered by these monster black holes. Supermassive is what we call them. Millions or even billions of times heavier than our sun. And they're not just sitting there. They're like cosmic vacuum cleaners gobbling up anything that gets too close.
So all that stuff spiraling into the black hole, that's what makes them shine so brightly.
Exactly. It's like a giant cosmic energy conversion machine. All that matter falling in gets turned into light and heat.
Yeah.
And because quasars are so ridiculously bright, we can see them from ridiculously far away. It's like having a time machine.
So they're giving us a sneak peek of the universe's baby pictures, basically.
Pretty much.
Okay, so this particular quasar that's got everyone buzzing, I think it's called J1429 plus 5447. What makes it so special? I heard it's breaking records for how far away it is and how fast it's changing.
Yeah, this one's a real record breaker. It's the most distant thing ever spotted by NASA's NuSTAR telescope. That's the Nuclear Spectroscopic Telescope Array for the long version. Right. So we're seeing this quasar as it was just a billion years after the Big Bang. And here's the kicker. Astronomers noticed its X-ray brightness doubled in just 4 months. Like from our perspective here on Earth...
Wait, hold on. Something that massive changing that quickly, it's hard to even imagine.
It's not your everyday kind of thing, that's for sure. And this is where things get a little mind-bending. We got to talk about relativistic time dilation.
Oh boy, here we go. Physics getting weird again.
It's all relative, right? So because this quasar is so unbelievably far away and its light took billions of years to reach us, those 4 months, we're seeing, well, those actually translate to a much shorter time for the quasar itself.
So we're seeing things in slow motion.
Kind of the opposite, actually. We're seeing things sped up. Because of time dilation, those 4 months on Earth are more like 2 weeks for the quasar.
2 weeks. So it's like this thing's changing brightness on a coffee break schedule.
Pretty much. That kind of rapid change tells us something wild is going on inside that quasar.
Okay, so 2 weeks for the quasar to double in brightness. That puts things into perspective for sure. But what could cause such a drastic shift in such a short time? I read something about a jet being involved.
You're on the right track. Scientists think this crazy brightening is caused by a jet of particles blasting out from the quasar. It's like a cosmic fire hose pointed almost right at us.
So kind of like our lighthouse analogy. But instead of a rotating beam of light, we've got this jet firing particles straight at Earth.
You got it. And because that jet is moving at nearly the speed of light, all those changes we see are amplified by the effects of relativity. That's why it looks so dramatic from our point of view.
So we're basically watching a cosmic fireworks show sped up thanks to the quasar's distance and some good old Einsteinian physics. This is really starting to paint a picture in my mind. But how does this flickering quasar and its jet connect to the bigger picture of the early universe? I mean, why should we care about a flickering light billions of light years away?
That's where things get really juicy. This quasar, with its rapid-fire changes, it's like a front-row seat to the evolution of supermassive black holes, how they formed and grew so quickly when the universe was still young.
Right, you mentioned earlier that supermassive black holes are at the heart of quasars. But how did they get so big in the first place? It's like watching a seed turn into a redwood tree overnight.
That's the million-dollar question, or maybe the billion-dollar question, given the scales we're talking about. It's one of the biggest mysteries in astrophysics. Well, remember those jets we were talking about, those powerful beams of particles? Some scientists think those jets might actually be the key to how these supermassive black holes manage to grow so quickly.
Okay, so the jets are both a sign of black hole growth and a way to control it. How does that work?
It's like a cosmic balancing act.
Hmm.
Think about it. When stuff falls into a black hole, it doesn't just disappear. It forms this swirling disk around it. We call it an accretion disk. This disk heats up like crazy and blasts out tons of energy, and some of that energy is what powers those jets we see.
So the jet's like this huge release valve, letting off some of the pressure from all that stuff falling into the black hole.
Exactly. And those jets, they don't just shoot out randomly. They can actually push away some of the matter that would otherwise be falling into the black hole.
So it's like the black hole is trying to eat everything in sight, but it's also kind of shooting itself in the foot by pushing some of that food away with its jet.
That's a great way to put it. It's a self-regulating system.
Mm.
The more the black hole grows, the stronger the jet gets. And the stronger the jet, the more matter it pushes away. Eventually, that slows down the black hole's growth.
It's like a cosmic tug of war between the black hole's hunger and its own jet.
You got it.
So this flickering quasar, it's not just a cool light show. It's giving us a glimpse into how black holes managed to grow so huge in the first place.
Exactly. And that's what makes J1429 plus 5447 so fascinating. Its rapid changes. They can help us understand how that whole balancing act works, how black holes feed, and how they limit their own growth.
It's like we're watching a cosmic drama unfold billions of years in the past. But hold on a sec. How do we even see this stuff? I mean, this quasar is incredibly far away. How do astronomers manage to observe something like that?
That's where some serious tech comes in. This discovery wouldn't have been possible without NASA's NuSTAR telescope. It's a space telescope that sees the universe in X-rays. It's like having X-ray vision for space.
So we're basically seeing the universe in a whole new light? Literally.
Exactly.
Yeah.
And NuSTAR is perfect for studying quasars because they emit a lot of their energy as X-rays. It's like they're shining brightly in a language NuSTAR can understand.
So it's like having a special decoder ring for the universe.
You could say that.
It's amazing how technology is constantly pushing the boundaries of what we can see and understand in the universe. But, speaking of understanding, I want to go back to something you mentioned earlier about the dark ages of the universe.
Yeah.
Can you remind us what those were and how this quasar fits into that whole story?
Sure thing. So after the Big Bang, the universe was a pretty crazy place. It was super hot and dense. But as it expanded and cooled down, protons and electrons started to combine, and they formed neutral hydrogen atoms. This neutral hydrogen, it was like a thick fog that filled the universe. It absorbed most of the light, so light couldn't travel very far. This period before the first stars and galaxies formed, it's what we call the cosmic dark ages.
So the universe was basically in a cosmic blackout, shrouded in this fog of hydrogen. And then something happened, something that ripped those hydrogen atoms apart and let light shine through. That's what's called reionization, right?
You're right on the money. And while we don't know exactly what caused reionization, quasars, like our flickering friend here, could be part of the answer. Remember those powerful jets we talked about? They're made of incredibly energetic particles, and as those particles travel through space, they can ionize neutral hydrogen, basically splitting it back into protons and electrons.
So it's like the quasar is acting like a cosmic flashlight, beaming its energy out into the darkness and clearing away that fog of hydrogen.
That's a great way to visualize it.
It's incredible how one object, so far away in both space and time, can give us clues about how the entire universe evolved. By studying this quasar, we're getting a glimpse into how the universe went from darkness to light.
Exactly. It's like piecing together a giant puzzle, and this quasar is a crucial piece that helps us understand how the universe transformed from this dark, mysterious place into the bright, star-filled cosmos we see today.
It really makes you appreciate how everything in the universe is connected. Even something as seemingly distant as a quasar can have profound implications for understanding the big picture.
Absolutely.
This deep dive has been an incredible journey, and I feel like we're just scratching the surface of what there is to learn about this amazing object. But before we wrap up, I'd love to hear your overall thoughts on this discovery. What are the key takeaways you want our listeners to remember?
I think the biggest thing to remember is that this flickering quasar, it's more than just a cool light show in the sky. It's like a window into the early universe, a time machine that's showing us what things were like just a billion years after the Big Bang.
A billion years.
Yeah.
That's like a blink of an eye in cosmic terms.
Exactly. And by studying this quasar, we're not just seeing pretty lights. We're learning about the fundamental processes that shaped the universe we know and love, how black holes grow, how the dark ages ended. It's all connected.
It's amazing how much information we can squeeze out of a single object so far away. When we look at this quasar, just how far back in time are we actually seeing?
We're looking back about 13 billion years. Imagine that. The light from this quasar has been traveling through space for 13 billion years just to reach our telescopes.
13 billion years. It boggles the mind. I wonder what those early astronomers, if there were any back then, would have made of this flickering quasar.
I can only imagine the look on their faces. It'd be like trying to explain a smartphone to someone who's never even seen a light bulb.
Huh. Yeah, good point. It really shows you how far we've come in our understanding of the universe. And yet there's still so much more to discover.
That's the beauty of science. It's a never-ending journey.
So true. This deep dive has been a real eye-opener, and I'm definitely feeling inspired to learn more. Are there any resources you'd recommend for our listeners who want to keep exploring these topics?
Definitely. NASA's website is a great place to start. They've got tons of info on their missions like NuSTAR, and they're always posting updates on the latest discoveries. There are also some great science news websites and blogs out there that explain things in a way that's easy to understand.
Awesome. I'll have to check those out. This has been a fascinating conversation, and I really appreciate you taking the time to break it all down for us. It's been a pleasure exploring the mysteries of the universe with you.
The pleasure was all mine. Always happy to talk about the cosmos. And hey, don't forget to keep looking up at the stars. You never know what amazing discoveries are waiting out there.
Well said. And on that note, a huge thank you to all our listeners for joining us on this deep dive into the heart of a flickering quasar and the early universe. Until next time, keep exploring the vast unknown.